Now let's look at this preemptive version of this priority based algorithm. So preemptive version means we are going to stop a process as and when a new process with high priority is available. That is called preemption. No preemption means we are not going to look at any other process. Once we have chosen a process with some priority, we are going to finish it off, right? So here you should be careful, I mean a bit careful. So let me just write this corresponding rows. It will be easy for us. Okay, now the first one at 0, at time 0, if I start it, the first process which is available is process P1. I have no other choice, therefore I am going to run it till what point. You should just see what is the arrival time of the next one. So next one's arrival time is 1, so you can run it only till 1 because the next one arriving is having higher priority. Therefore you preempt this and you put the next one. So what is next one process? Next process is P2, and now P2, how much should I run it till the next one is available? So next one is available at time 2 and it's having higher priority. Therefore run it for only one unit of time and then schedule the next one. And how long should I execute the next one? P3. So till the next one is available. The next process is available at 3, therefore run it till 3 because the next process is having higher priority. In case if the next process is not having higher priority, you can keep executing the same one, right? But here it is next process is available at 10, therefore take it and schedule it. So P4, how long should I run it? Till the next one with higher priority is available. See this? So next one's priority is 8, but it is arriving at 4. You need not stop for it. The reason is this is having higher priority compared to 8. Therefore you can run till 5 because only at 5 a process with higher priority 12 is available, right? Therefore run this one till 5, no problem, right? And at this point we are going to schedule this P6 because it is having the highest priority. And now if you watch it, it is having the highest priority and it need not be stopped at all. It can be run till completion. So now to complete it, time taken is 4, therefore run till 9. And one more thing, whenever you are running a process and then preempting it, just keep track of its remaining burst time. Here the P1's burst time is 4 initially, but then it has run for 1 unit, therefore the remaining burst time is 3. And P2 burst time is 2 initially, it has run for 1 unit, therefore its remaining burst time is 1. And P3 is 3, it has run for 1 unit, therefore remaining burst time is 2. And P4 is actually 5 is the burst time, but it has run for 2 units, therefore remaining burst time is 3. And coming to this P5, it has not been scheduled yet, but P6 has run to completion, therefore P6 is over completely, right? This is over completely. Fine. And now the time is 9 and all the processes are available. Now it is up to you. You can choose the one with the highest priority, and from here on it will be non-preemptive version. The reason is once all the processes have arrived, now we are just going to see the priority, and whichever is having highest priority will take it directly, right? So now among all this, which one is having highest priority? The remaining one. 12 is over. So if you look at the numbers, next one is 10, isn't it? Therefore P4 will be scheduled. And how long should it be run? It should be run for 3 units of time, right? Isn't it? Because that is the time remaining. So 3 units is nothing but 12. So 10 is over. Now after this, what is the next available process? The next available is 9. Highest process is 9, and it's if you schedule it, which is P7, it is going to run till completion till 6 units. Therefore 18, and it will be over, right? So this is over. And among the remaining, what is the next one? 8 is the next one, right? So you can take the P5, and what is its remaining burst time? Watch it. It has never been scheduled before, therefore its burst time is 1, and I am going to run it till completion. Therefore till 19 I will run it. It will complete, right? And then the next one is in the remaining one, the next highest priority is 8. So if I take it and schedule, 8 is over, right? Yes, just now P5 is over. And in the remaining one, which one is highest? 6, 4 and 2. The 6 is highest and its remaining burst time is 2. Therefore I am going to schedule P3 and run it for 2 units, and it is going to be finished. And what is its 2 units, right? Which means 21. Fine. And in the remaining one, we have only 2 processes. One is 4, another is 2. So I can take P2 and I can run it for how much time? The remaining burst time is 1, therefore I am going to run it for only 1 unit, and it is going to be over here, right? And then P1, its remaining burst time is 3, finally 25. Got it? So that is how this could be done. So only one thing you should be careful here is, we are going to run a process till that point until which a process with higher priority becomes available. So whenever a process with higher priority becomes available, you are going to preempt this process and schedule that higher priority process, right? But then once all the processes become available, then you are going to pick the one with highest priority, and since no more process is going to arrive at later point, you can run it till completion. Therefore at some point this non-preemptive version, this preemptive version will convert to the non-preemptive version. At what point? When all the processes have arrived. It is exactly same as shortest job first. Even in shortest job, we are going to run a process until the next process with lower burst time is available. But then we are going to do this only until all the processes are available. Once all the processes are available, we can directly go in the decreasing order of increasing order of burst times, right? There is a correlation, right? One algorithm is converting to other algorithm after some point of time, isn't it? Now in case if all the processes arrive at the same time with all the priorities, right, which means arrival time is all same, 1 1 1 1 1 or 2 2 2 2, arrival time is same, then non-preemptive version and preemptive version will be exactly similar. The reason is, you are going to pick the one with the highest priority and no other process is going to arrive at later point of time, therefore you are going to run that till completion. So it is exactly same as non-preemptive version, right? Even in shortest job first also, if all the process arrive at the same time, then non-preemptive and preemptive version will be same. The reason is, we are not going to get a shorter process with lower burst time at later point of time, right? So just it is interesting to know it. Okay. And now let's finish this completion time and other stuff. This rough work, I just want to delete this rough work. See, one more thing, I am able to do this given this table, but in your examination what they give is, they will give you a paper, this is online, they will not give you a paper. You have to see the question from the screen and then copy it on the paper and then solve it. So while you are copying the numbers from the screen onto the rough paper, be careful that you don't copy something wrong. If you copy anything wrong from there to the paper, then answer is going to turn out wrong. See, these questions are very simple and you should not do any calculation mistakes. It is very simple to get some calculation error here and there, but then just be careful, practice a lot. Now what about completion times? Since this is a preemptive version, you are supposed to check the completion times from the right end, right? So what is the completion time for P1? P1 got completed 25. And what about P2? P2 got completed 22. And P3 got completed 21, P4 got completed 12, P5 got completed at 19, P6 got completed at 9, and P7 got completed at 18, isn't it? Let me check it. P1 is 25, P2 is 22, P3 is 21, and P4 is 12, and P5 is 19, and P6 is 9, and P7 is 18, right? And after that you can find out the turnaround time. Turnaround time is difference of these two, right? Completion time minus arrival time. So here it is 25, 21, 19, 9, right? And what about this 15, and what about this 4, and what about this 12, right? Completion time minus arrival time. Fine. After finding the turnaround time, we can find out the waiting time and then the response time. See, in this case, response time and waiting time will be different. I'll show you the difference why. See, earlier, if you see P1 got scheduled only at one point, but now P1 got scheduled at 2 points. Therefore, P1 is waiting for the entire duration, right? So for the entire duration between all this, from here to here, P1 is waiting. Therefore, waiting time is more and response time is less, isn't it? Response time is the point at which it gets scheduled first. That is the point on which response time depends on, but waiting time depends on the entire duration, right? Okay, now let's see what about the waiting time for P1. Waiting time is turnaround time minus burst time, this one minus this one, which is 21 here, and it is 19 here, and it is 16 here, 4 here, 14 here, 0 here. Waiting time of P6 is 0, fine. And then waiting time of this one is what is this, 7, right? Waiting time of this one is this one minus burst time, which is 6. Turnaround time minus burst time, which is 6. Okay, now if you observe it, only process which is having 0 waiting time is the process having highest priority. So whenever you have a process with highest priority, you are going to complete it right from whenever it arrived. It will get the first priority and will get finished, then only other process will execute. That is why that only that process got the highest, this waiting time as 0. So in case if you have ever anytime you get a process with highest priority, always remember that in this scheduling, which means the scheduling is preemptive version. In preemptive version, it will get the waiting time of 0. In non-preemptive version, it might not get a waiting time of 0, because if there is some other process already running, we are not going to stop it for the high priority process. But here, whenever we have high priority process available, we are going to stop the other process which is running. That is why here we get a 0. And what about the response time? Now response time depends on when it arrived at the first time, right? Now see this, P1 is scheduled at 0 and it arrived at 0, therefore response time is 0. P2 has arrived at 1 and it got immediately scheduled at 1, therefore it is 0. And P3 got arrived at 2 and it got immediately scheduled at 2, therefore 0. And P4 arrived at 3 and it got scheduled at 3, therefore 0. And P5 arrived at 4 but it got scheduled at 18, therefore its response is 14, isn't it? Check that. And then P6 arrived at 5 and it got immediately scheduled at 5, therefore its waiting time is 0. And P7 arrived at 9 but P7 arrived at 9, P7 if you watch it, yes, it arrived at 9, it arrived at 6. P7 arrived at 6 but it got scheduled at 12, therefore its waiting time is 6, right? So only these two are having response time which is non-zero. And why is the response time of all these 0 is remaining process 0 is as and when they are available, they are the highest priority process available till then. That is how we got the process one by one. If you watch it, we got the process in an increasing order of priority. Therefore, as and when they are available, they are immediately scheduled until the next one gets available, next highest priority process gets available. Therefore, in this model, whenever the process which has arrived is higher than is having the priority which is higher than all the process which have already been present, then that is going to get a response time of 0, because it is going to be scheduled immediately, right? Okay, even if you didn't understand theory, whatever I was trying to say, right, whatever I have been speaking till now, if you understood this method, how to solve it, it is fine, it is perfectly fine. They will not ask you so much depth. Okay, and now you can find out what is the average turnaround time, what is the average waiting time, and what is the throughput. So what is the throughput of this? We started at 0 and we finished at 25, therefore the total schedule length is 25, and in this 25 units, how many processes did I finish? 7 units, right? 7 processes. Therefore throughput is 7 by 25, isn't it? So the throughput is number of processes which are finished per unit time. 7 processes got finished in 25 seconds, therefore 25 units, therefore throughput is 7 by 25. Okay.